Hey guys, so today we are talking about polynomials, and those are new. They kind of look like this. They have a bunch of different shapes, but it just means that we're moving on from straight lines, which are called linear, and away from quadratic. Those are also polynomials. And now we're going to start dealing with some like squiggly type ones. So the bronze part is not any different from quadratics, which is why I started talking about them. So our zeros or our roots are just where y equals 0. So that means anywhere along the x-axis, anywhere that our polynomial touches is going to be a root. So here would be a root, follow along the one would be here, go up and around, this one would be here. So we would say the roots of this first function are -3, that's in between 0 and -1, so I'd probably say -0.5. Right, I'm just estimating, and then my last one would be 2. So I can do the same thing on my second graph. I'm going through here, anywhere it touches the x-axis, it looks like maybe about 3.5, and right about 7, maybe a little bit less, maybe 6.9. I'm just estimating. You could put 6.8, you could put 7. There's not a huge thing here. We're just approximating because it's not a very specific graph. Okay. When we're looking at our y-intercept is the same as normal. The y-intercept is where x equals 0. So here's where x equals 0, and that's going to be this whole line here, right? So it's wherever it touches the y-axis, which is right here. And we can see that the y-intercept of this first graph is between 1 and 2, 1.5 probably. Right? And then we can see here on this graph, it's right there. We see that this counts by 2's here. So 6, 7, 8, and it's in between 7 and 8. So our y-intercept for this one is probably 7.5. Easy peasy, you guys have been doing this a million times before. Maximums and minimums are the same, except we can see that there are more of them. So a maximum is the highest point, right? So highest point, and this one would also be the highest point. So I'm going to go through these graphs, and I'm going to look here. Right, so I see a maximum there, and I know that this is a maximum because all the points around it are below, right? We would call this a relative maximum because all of the points around it are lower than it, but we can see that there are other parts of the graph that are higher than it. So it's not the absolute, it's not the biggest maximum ever, it's just the relative one. It's relative to the points around it. We can also say that about this point here. So we can see this relative maximum there and a relative maximum there. It's not the highest point on the graph, but it's the highest point comparatively to the points that are right around it. Right, so we can see that. So relative then would mean around, right? The highest point around. Highest point around. So then when we're thinking about minimums, right, these are the lowest points. Lowest points. And those are like this point here would be a minimum, right? And when we're thinking about minimums there, this is the lowest point around it, but again, not the lowest point ever. So we would call this a relative minimum, right? A relative minimum. Same is true for this point here, right? That is also a relative minimum. Absolute, on the other hand, would be the minimum point. Sorry, let me go ahead and erase that. The absolute minimum would be the lowest point of the whole graph, right? Lowest point of entire graph. And this is the point that is really, really like the bottom of the graph. So that would be this point over here. We would call that an absolute minimum because it is absolutely the lowest point of the graph, right? And that's about it. So we have our zeros, our y-intercepts, our relative maximums, and our relative minimums. Thanks, guys.